Okay, this is a 6 marker. As always, breaks down into 3 different stages. We've got information here about the molecular formula. We've got information about the bromine test and what that means about A, B, and C. We're given information about which ones of these are stereoisomers. And you've got to work out what the different structures are, and you need to be able to explain what stereoisomerism is. As is always the case in 6 markers, or certainly in the vast majority of cases, it breaks down into 3 different phases of the answer. We need to talk about the saturation and unsaturation of A, B, and C. We then need to deduce the structures, and we then need to explain what we mean by stereoisomerism and why compound B shows it. So you're taking lots of different components from different topic areas and bringing them together into this 6 marker. Now, the saturation unsaturation, we know that A and B are unsaturated and C is saturated. So we're on the way to completing the first of the 3 phases here. We need to explain it a little further. We know that A and B are unsaturated because they do decolorize the brown bromine water. That's the double bonds being broken. And we know that C is saturated because it doesn't decolorize brown bromine water. So we've got one section done, and we then move on to deduce the structures. Now, these are not the only answers. These are not the only ones that you can put down, but these are the most straightforward ones. A and B will both decolorize bromine water. So we know that they are both alkenes, but we know that C isn't an alkene. It's still C5H10. It's got the same general formula as an alkene. So what we're thinking of for C is functional group isomerism. And the functional group isomer of an alkene is a cycloalkane. So I've gone for cyclopentane here. You could have gone for methyl cyclobutane. It would still get you the mark. Now, what we also know is that A does not show stereoisomerism. So I've gone for the most obvious example there. It's going to be pent, and the double bond is going to be on the first carbon. That means that there'll be 2 H's coming off one of the carbons on the double bond. So we can't have a geometrical isomer, a stereoisomer. So pent 1-ene. And for B, B does show stereoisomerism. And that means that each of the carbons in the double bond has 2 different groups coming from it. Now, pent 2-ene does fit that criteria. So I've written the names out here. You would be going on to draw out the structures of these rather than just name them. Finally, explaining stereoisomerism. First of all, start with the definition. Always a very good place to start. It's the same structural formula, but a different arrangement in space or spatial arrangement. There's no free rotation about the double bond, and that's what actually gives rise to it. And as I've already touched on when we were deducing the structures earlier, each carbon in the double bond has 2 different groups coming from it. So where do the marks come from on this? Well, again, there's a familiarity on 6 markers. If you've covered all 3 of the stages and they are virtually correct, you've given all 3 correct structures, and your answer is logical and coherent, you get into level 3 and you're going to get 5 or 6 marks. To get to level 2, you need to have done 2 of these stages completely, or you've got to have attempted and covered 3 of them to an extent. And for level 1, you've got to have completed 1 stage completely, or you've got to have attempted and completed to an extent 2 of the stages.